Good morning, students. Today is June 21st. This is Math 2008. We're going to record our lesson. We're going to be working on Chapter 6, Section 1. If you go to your assignment section, you will see the assignments for Section 1. I'm just going to say 6.1, 6.2, and 6.3 are ready. By the end of today's lecture, you should be able to do problems from 6.1. We will do 6.1 today, we'll do 6.2 tomorrow, and we'll do 6.3 next week. That's the plan, okay? I looked at your grades. Most of you did well on the exam. Um, our next exam is on July 3rd. July 3rd. So let's move on. This section is about fractions. It's not, I would like to say it's not a very difficult concept for most of you because you've done it. So where do we see fractions? Okay, let's first talk about integers, okay? Integers, and we have talked about it in the past, but we'll talk about it again. Integers are these numbers. Okay, we discussed it when we discussed chapter 1, but we will talk about it today a little bit, so might as well redefine it. Nothing too fancy. Integers are these numbers. Okay, 0 plus minus 1 plus minus 2 plus minus 3, so on and so forth. It goes on and on in both directions. So fractions are numbers where you have something that looks like this. 1 divided by 2 is a fraction. Or a rational number. Okay, they're the same. We're going to use the words interchangeably. Fractions or rational numbers. 3 over 2. Okay, another one. Now you can argue this is a rational number too, because this divided by, there is a little 1 in the bottom. Okay, so basically any number that can be expressed as a number divided by another number, except for the number you're dividing by cannot be 0. Okay, so you cannot do this. That's not defined. 3 divided by 0 is not defined. You cannot divide a number by 0. So that's out. So basically a fraction that can be expressed as a number being divided by a second number, and that second number cannot be 0. An integer being divided by a non-zero integer is a fraction. All right? Now, the top number is called numerator. I'm going to write it down. I'm going to write down a few words here. Numerator. And the bottom number is called the denominator. The bottom number is called the denominator, and fraction is a fraction. We also use the word rational number. So let's write down rational number. All right. Now, here are some of the instances when we see a fraction. This is just a slide from chapter 6, section 1, division problem or solution to a multiplication problem. So if you have an equation, 2x minus 3, what's x? 3 over 2. Here we see a fraction. Joe received half of Mary's salary each month for alimony. So Joe got some money from Mary. He got half of what Mary made. So that half is a fraction. Ratio. Ratio is also a type of fraction. Basically, the ratio of Republicans to Democrats on a Senate committee is 3 to 5. That 3 to 5, we write it like this. Oh, let me erase some of these things, okay? Okay, 3 to 5 is written like this traditionally, but this also means 3 over 5. They are the same. They can be used interchangeably. The last one, when we encounter probability, we express probabilities as fractions too. When you toss a fair coin, the probability of getting heads is half, 1 over 2. There's one head out of two options, so it's 1 over 2. So basic cases when we encounter fractions. One more thing before we move on. If you have a numerator strictly larger than or equal to the denominator, you call it an improper fraction. These are the examples, okay? Improper fraction. When do you know something is improper? The numerator is larger than or equal to the denominator. Okay, so 1 is also an improper fraction. All right, what's a proper fraction? In a proper fraction, the numerator is strictly smaller than the denominator. 2/3, 1/2, and so on. All right. So before we move on, well, let's talk about mixed numbers. Mixed numbers are numbers that look like this. Mixed numbers are numbers that look like this. So you have a whole number part. This is the whole number part, and you have a fractional part. All right. So this is called mixed number. This is a mixed number. Okay. Now, what we're going to do, we're going to learn mm, improper fractions. Improper fractions are generally more than one. They can be one or equal to more than one. When you have an improper fraction, how do you convert it to mixed number? When you have a mixed number, how do you convert it to an improper fraction? Let's do that first. So let me take this, write it as follows. This is my example, 2 1/3. Okay. So let's say you had two whole cookies and 1/3 of, excuse me, suppose you had two whole cookies and 1/3 of the next cookie. So what is it in terms of mixed, in terms of improper fraction? What you do is you take the denominator and multiply it by this uh, whole number part, you get 6, and then you add 1. So that's 7. And you keep the denominator the same. So 3/7. Okay? If I give you 3/7, how would you get to mixed number? Let's try one of those. So this is called converting an improper fraction to mixed number. Now, I don't want to do the example that's right over there. Let's do something like this, 8 divided by 3. Uh, how do I convert it? So basically try to divide 8 by 3. And unfortunately, I have to do it like this. I don't have a good way of doing it. 8 divided by 3. So 3 times 2 is 6. What's the denominator? 2. Okay? So now this answer, actually, guys, let me give you one more example, okay? I have two twos here. The remainder is 2. The quotient or the answer is 2. That's going to confuse you guys a little bit, okay? So let me take something like 11 divided by 4. Let's try this, okay? This is clearly an improper fraction. I'm going to convert it to mixed number. You're going to divide 11 by 4. 4 times 2 is 8, and the remainder is 3. Okay? Now, this is going to be equal to, this is going to be equal to 2 is the quotient 2 from your division, and 3 is the remainder, and 4 is the same denominator, 4. Now, if you test it, did you get it right? Very easy. 4 times 2 is 8. 8 plus 3 is 11. 11 goes on top like we did before, and 4 is 4. So it is correct. Okay? So we just learned how to convert mixed numbers to improper fractions and how to convert improper fractions to mixed numbers. Okay, guys? Let's move on. So this is important. Actually, this slide is very important. You're going to see it in any American textbook. So when you express fractions, it can be done numerically. It can also be done visually. So the first one in all these problems, well, the first one shows 1/3. So 1 out of 3 equal parts. So this is 1/3. And you want to understand the visual representation as well. And this model is called bar model because it's represented in terms of bars. Bars can be horizontal, bars can be vertical. Here it's horizontal. In this model, it's very similar to the bar model, but it's on a line. It's called number line. It's called the number line model. Make it a little bigger for you guys. Here you have 2 out of total of 3. So this represents the fraction 2/3. The last one is called set model. Some people say discrete model. Here, let's say you have five cookies. 3 of them are chocolate chip cookies. They have been shaded. What fraction are chocolate chip cookies? You would say 3 out of 5. So these are 3 types of representations of fractions. They're all visual, but one is called bar model or area model. Other one is called number line model. Third one is called um, set model or discrete. You can say discrete. Let me see if I can spell it right. Discrete model. Both are correct. I've seen both. Now, do you have to remember these terms? Not really. You don't have to. I want to ask you describe the discrete model or set model. Um, However, you want to be familiar with all formats because you will see them in our problems and you will also see them in your books, the books that you will use to teach. Okay? Well, this is a good one too. So here they're trying to show why 1/3, 2/6, and 4/12 are the same. Now, this is 1/3 because one part was shaded out of 3 parts. Now, if you take each of the 3 parts, split them further into 2 equal pieces, now you can say that 2 out of 6 have been shaded. Okay, you took the same original 1/3 and split everything into 4 pieces, equal pieces, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Now you have 12 equal parts and 4 of them are shaded, so you can call it 4/12. This is a very nice way to see that 4/12, 2/6, 1/3, they're all the same, they represent the same amount, they represent the same fraction, they're equivalent. So this is a very important figure, guys. This shows you that 1 is cut into 3 parts. And well, let me show you a better model. I have a picture that's better than the one in your book. Okay, let me see if I can grab it. Give me a second. This is slightly better than the one in your book. So guys, this helps us see that 1 is same as 2 halves. So I split 1 into 2 equal parts, each is half. Then I split the same 1 into 3 equal parts, each is 1/3. I split the same one into 4 equal parts, each is 1/4, so on and so forth. But the beauty about this is it helps students see that 1/2 is larger than 1/3, 1/3 is larger than 1/4. You and I are adults. We are adults and we can see those things. We understand them, but kids don't. Sometimes kids incorrectly say 1/3 is bigger than 1/2 because 3 is bigger than 2. That's completely incorrect, right? So once they see fractions in this format, they can relate to that difficult concept. You can ask questions like when you use, this is called a fraction wall. When you use a fraction wall in your class, you can ask them questions like 1/2 and 2/3, which is bigger? Clearly, 2/3 is bigger than 1/2. Which is bigger, 2/3 or 3/4? Clearly, 3/4 is bigger than 2/3. So you can do all sorts of activities, and students can make their own fraction wall. This is called a fraction wall. Of course, this is an informal name. Students can make their own fraction wall. Do you have to go all the way up to the 10th? Not really. Do up to 1/5. They will see the pattern. And it's a very fun activity for young children. Okay. It's in your book and we did it. We discussed it. Now, this is a basic property of fractions. Most of you know it, I'm pretty sure. So what this is trying to say, if you have a fraction, any fraction, assuming the denominator is not zero, let's take 3/4, you can multiply the top and bottom by the same number. So I'm going to multiply the top by 5. 3 times 5 is 15. And 4 times 5 is also, 4 times 5 is 20. So 15 over 20, 15/20ths is same as 3/4. All right. Using the opposite of that, you can always do something like this. Let's have 25 over 35. You can divide 25 by 5. Find a number that both numbers, numerator and denominator, are divisible by. 25 is divisible by 5. 35 is divisible by 5. If you divide 25 by 5, you get 5. If you divide 35 by 5, you get 7. They're equivalent. So you can go in both directions. Okay? Nice example from your book. All right, guys, that's all we have from 6.1. Okay. I'm going to do some of the examples from your book. They are really also on Blaze, on MATLAB. So it's the same. I grabbed some from the book. I grabbed some from MATLAB. For instance, this one is pretty straightforward, except for I think part B is a little tricky. So there's actually part A and B. So what I'm going to do is for each of the following, write a fraction to approximate the shaded. So this one will be 2, 2 out of how many total? 6. So this is easy, 2/6. I'm going to write it right here, 2 over 6, piece of cake. This one is shaded 1, 2, 3, 4, 5, 6, 7. 7 out of what? 7. How many are total? I'm getting 12, unless I've made a mistake. 7/12. Okay? All right, so this one, guys, you cannot say 1 out of 4, okay? When we talk about fractions, everything must be cut into equal parts. So I'm going to do it like this. If you cut it into equal parts and go ahead and cut it, this represents 1/6. Now, what I have here is you want to find out if the shaded portion is one of the equal parts of the whole. What part of the whole is shaded? Well, make sure your shaded portion is one of the equal parts by extending the lines the way I extended. I'm getting 1/6, not anything else. Here, here, what would you do? Well, I'm going to cut it like this. I have to make this green shading an equal part, and the best way to do it is like this. So ignore this line, pretend it's not there, and ignore this line. Now your whole WHOLE is cut into 4 equal parts. One of them is shaded, so this is 1/4. 1/4. Okay? Not really that difficult, I think. I'll let you be the judge. This is something we've already discussed, but it's worth repeating. So what they're trying to say is, for each of the following 4 squares, write a fraction to describe the shaded portion. What property of fractions does the diagram illustrate? Well, the first one is 2/3. 2/3. The second one is 4/6. 4 parts are shaded out of 6 equal parts. And the next one is 6/9. 6 of the equal parts are shaded out of 9 equal parts. And the one after that, the fourth one, is 8/12. Well, what property of fractions? Equivalent property. They're all equivalent. They all represent 2/3. Okay? All right, so this is also simple. This time you have to physically do it. You have to show that 1/4 is the same as 2/8. So you have to cut this square. We're doing part A, into 8 equal parts. Well, how do we do that? 8 equal parts. You can do it in a variety of ways, but I'll do it like this. We have to assume they're really nice and equal. Now I cut my square into 8 equal parts. I'm supposed to shade 2 of them, and I will shade this. Okay, I shaded 2/8, which is same as 1/4. Here, I will cut it into 3 equal parts. So it's going to be a little messy for me, guys, because I'm doing it freehand. Won't look perfect, but that's okay. It looks terrible. My bad, guys. I took each sliver and cut into 3 parts, and I'm going to shade the bottom 3. So it's going to be 3/9. Okay, let's try to do a slightly better job here. Let's see if I can. So what I'm going to do, guys, I'm going to want to cut the bottom part into 3 parts, and so the top part as well. I did cut my hexagon into 6 equal parts, right? And I'll shade the 3, any 3, but I'm going to try to be, I will try to match the picture on the left. So now I've shaded 3/6. Okay. All right, guys, so let's try this problem. This is from your MATLAB. It's a problem from MATLAB. Let's see how we can solve this problem. If a fraction is equal to 4/5 and the sum of the numerator and denominator is 63. So let's start with 4/5, okay? Let's start with 4/5. Now, clearly, 4 plus 5 is 9. That's not 63. So let's multiply both top and bottom by 2. Let's see what happens. 4 times 2 is 8. 5 times 2 is 10. Well, this time sum turns out to be 18. 18. So if you keep on doing it, when do you get 63? Multiplied by 3, it won't work. I think it'll work with 7. 4 times 7 is 28. And 5 times 7 is 35. And 35 plus 28 is 63. Another way to test this, guys, the way I found 7, this is what I did. I added 4 and 5, that's 9. And I divided 63 by 9, and I got 7. So basically, if you multiply 7 times, if you multiply 7 by 4 and 5 by 7, your sum is bound to be 63. So you can, this is trial and error. Okay, you keep on doing it till you hit 63. This is a little more direct. Okay. So guys, we're going to solve these two problems for X. Okay. I'm going to actually do part B, if you don't mind. So let me rewrite it. This is also from MATLAB. 2 over 5 is equal to negative 18 over X. Now, uh, I don't need this. I'm solving for X. So what I'm going to do, guys, it's called cross multiplication. When you have an equal sign, you can multiply the numerator and denominator, and set them as equal. Okay, that's a legitimate step. And it's really not that difficult to see. If you multiply both sides by 5 and both sides by X, you will get everything on one line. And that's really what cross multiplication is. And we tend to put X on the left-hand side. 2 times X is 2X. And 5 times 18 is negative 90. Let me double check. 50. Yes, that's correct. So now I can divide both sides of this equation by 2. If I divide the left-hand side by 2, my 2 is gone. And if I divide the right-hand side by 2, I get negative 45. That's my answer. So let's try one more problem. Okay, again, I'm going to try I'm going to try B because A is fairly straightforward. You should be able to do it. I'm sure you can do B as well. But I'll go over a few things. 5 divided by X squared. Okay, it's understood that X is not 0. Okay, it's understood. So if that's the case, if I divide both sides, when you have an equation, whatever you do on the left-hand side, anything legitimate, you have to do the same legitimate thing on the right-hand side or to the right-hand side. And once you do it, if you do it, your equation remains unchanged. So I am gonna divide both sides by 5. That's how you say it. I'm gonna divide both sides by 5, multiply 1/5, both sides by 1/5. This is gonna be 1. And this is also gonna be 1, and we don't write 1. Now, this x here and x squared will cancel. I'll show you what I mean. Well, x squared can be written in the bottom as x times x. Now, I can't put a multiplication sign because my multiplication sign looks just like x. So I'm going to cancel these two as follows, right? And what do I get? I get 1 over x. Now, you can't solve this. Well, it has infinitely many solutions. This equation is true for all values of x as long as x is not 0. If x is 2, this is true because half is equal to half. If x is 3, this is true because 1/3 is equal to 1/3. If x is 4, it's true. 1/4 is equal to 1/4. 0 is the bad guy. We'll say if you have to solve for x, you will say all real numbers except for 0. Excuse me. Oh, I want to get rid of that. All right, guys, I'm going to get rid of this. So this is an interesting problem. It has infinitely many solutions, okay? All real numbers except for 0. So guys, that all I have for 6.1. You should be able to do the problems from 6.1, try them and practice them. Our next exam will be on July the 3rd, before July 4th. All right, see you next time. When I say see you next time, I mean through video. All right. I don't mean you have to come and talk to me, but you're most welcome to. Another thing, if you don't understand any problem from MATLAB, please email me and say, could you do this? Tell me your name of your class. I'm teaching 3 courses, and and give me the good clear screenshot. Some of you send me the link, that works too. Thank you. Bye bye.